Okay, this is Mrs. A with a recap on today's lesson on slope. So today we were on 3.5, day 1, slope-intercept form of linear equations. So we've been learning a lot about linear equations and how the equation results in a graph that is a line. And so now we're going to learn about that line and how steep it is. And we call that the slope. So that's the definition of slope. Slope is how steep a line is. Let's see how steep a line is. And we have a lot of words over here, but where I want you to focus on is that slope here, that equation. And the variable that we typically refer to as slope is m. And that variable is going to give us a description of what slope is. That variable is going to help us understand how steep that line is. And is it rising? Is it getting taller? Or is it falling? Is it decreasing? And so the way we define m is it's a ratio of two numbers. It's a ratio of what we call the change in y to the change in x. This is also known as rise over run. And then on the right side, we can start to see the variables that come into play. But let's first just start by looking at what run and rise is. So rise is the distance between 2 points on a line. It's that distance between the y values of those 2 points. So we're looking at how much up we're going from the first point or down. That's our rise. And that's why they call it rise, because rise represents that y axis, and so we're either going up or down. Run is going from left to right. That's going across our x-axis. And that's the distance from the first point to the second point, but going across the x-axis. So that's a lot of new concepts that I just covered. I think a good way to look at this is to see it in action. And let's try this with a problem. So we have described the slope of each line, then find the slope. So when I look at A, I want to describe the slope. First thing I want to do is take a look at the line and think about what are the 2 points that are identified on the line. And you notice how we typically look for points that fall on integer numbers? That's because it makes it easier for us to work with them. So when a line, we're looking for points to figure out the slope, we're usually looking for the integer numbers. So let's start with the rise. And I'll use, let's say, orange for the rise. So this here is the rise. And the rise is that change in y. It's going from -2 all the way up to 2. So that rise, if I go from that first point, which would start over here on the y, and I go up, 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 I see how it gets me all the way over to here. And that rise, that's part of the definition of my slope. And if I count the boxes that go from the bottommost point to the topmost point, I get 1, 2, 3, 4. So I have a rise of 4. Now, what about the run? So part of my slope is going to equal to the run. Let's take a look at the run. So the run is this over here. And it's the distance between the first point and the second point, but in terms of x. So if we have -3, and we're going to go all the way up to 3, that's the distance between -3 and 3, which is 6. I can see that by counting the boxes along the x from the first point to the second point. 1, 2, 3, 4, 5, 6. And that gives me my run. So rise over run, that's what is equal to my slope. It's a ratio. And so for this graph, my slope is 4 over 6. Since ratios are fractions, they can be simplified. And 4 over 6 has a common factor of 2. So I can reduce this. I can take out a 2 from the top, I can take out a 2 from the bottom, and that would get me a slope of 2/3. And so that's how I would describe this one. Let's try B. So with B, you see the distance is on the right-hand side for the y. Notice how this time we're going down. So our first point, if we start from 0, 2, and going down to our second point to -1, you see how we're going down by -3? You know that because if we count the boxes from the top point down to the bottom point, you get 1, 2, 3. Okay, and notice how we're going down, so we're going to call this the -3. So let's start my slope by saying m is equal to rise over run, and that's going to equal to -3 is my rise. And now let's look at what the run is. So the run is going to be over here. I'm going to look at between the 2 points. I'm going to look between the first point and the second point along the x-axis. So let's see. If I go from 0 over here, and then I go over to 2 here, that's a distance of 2. So my run is going to be 2. And that is my slope. Now that might look like an improper fraction, but for us it's a ratio, and we want to keep it in that format. So we're going to actually keep slope as described as -3 over 2. There's really no changes I want to do to that. So I would write -3 over 2 as my answer. So why don't you give it a try? Pause the video, and when you're finished, start the video again. Okay, so what I would do again is I'm looking at the line, and the points that I'm interested in are, I'm looking at the -2, -3, which is over here, and I'm looking at the 1 and the 3, which is over here. Now, if I want to find my rise, I'm going to be looking at this distance here, going all the way up to the first point. So I'm going to draw a line that goes up like that. That's going to give me my distance for my rise. So let's count the boxes. That's 1, 2, 3, 4, 5, 6. So my rise is 6. Now let's look at the run. So the run is going across, and so I'm going to start from my -2 to -3, and it's going to the right, so it's increasing, so it's a positive number. So my run, I can count that out, it's going to be 1, 2, 3. That's 3. So my slope is going to be m is equal to rise over run, and that's going to equal 6 over 3. So 6 over 3, that can be simplified to, has a factor of 3 in the 6, and it has a factor of 3 in the 3, and so we can write our slope as m is equal to 2. That's our answer. Okay, let's try one more together. You give it a try first, and then put the video on pause, and when you're done, come back. Okay, so first I'm going to look at what are my points, and I see my points here and here. I've got one point at negative 2, 0. And they chose that point because it's an integer point. And if we look at the other point, it's 2, negative 2. So let's first see if we can describe the rise. So my rise is going to be, look at this, I'm going to go, sorry about that. I'm going to go up 2 to get to the other point. And so that is a rise of 1, 2. That's my rise. And then I'm going to look at my run. Now notice how I'm going left instead of right. So move it a little bit below that x-axis so you can see. But that distance there, that is going to be 1, 2, 3, 4 boxes to my left though. So I'm going to make this a negative 4. Okay, and that is my run. You notice why they call it rise and run? Rise is going up and down. Run is going from left to right. So my slope is going to be equal to that rise over run. And let's see, the rise is equal to 2. And the run is equal to negative 4. And again, I can simplify that. There's a common factor of 2 in the numerator and the denominator. And so that would give me m is equal to 1/2. Negative 1/2. Let's not forget that negative there, okay? And that's our answer. Now notice that when it's a negative slope, the direction of that, let's use blue, the direction of the line, if you're going from left to right, it's decreasing, it's going down. That negative helps us see that. That's why the slope describing a line is so helpful. We can actually look at it and see how steep is it by the number, the value, and we can see what direction that line is going by the sign. So if you notice the one that was going up, if we're going from left to right, you notice how this is going up? Well, that's a positive 2. Okay, so if it's rising, if it's increasing, it's a positive. If it's falling, if it's decreasing, it's a negative. All right, so a couple of summary from that and some additional information is if it's a positive slope, the line rises from left to right. If it's a negative slope, the line falls from left to right. Slope of 0, well, the line is horizontal. And it kind of makes sense, right? Because we can't go up for y. There is no increase for y. So that increase, that rise is 0. Okay, so we end up with a slope of 0. And for a vertical, well, I'm going to save that for another day, but here's a little hint. It's undefined. And it has to do with the fact that rise over run, well, that run, it doesn't, we don't make any change in x. There is no change in x. And so that change in x ends up being 0. Well, I don't know. If you take out your calculator, you'll see if you divide any number by 0, you get undefined. Okay, that's why our vertical lines are have an undefined slope. All right, so I hope that helps you do your homework tonight. I'm going to include in a separate video, if you find you're able to get through this and these homework questions, part 2, where we get more into the tables and how we can also look at slope from a table. Okay, have a nice day.